So here's an extra examples on sketching logarithmic graphs, so natural log, as well as we'll look at some reciprocal graphs and the exponential graphs, because these are the ones that cause problems and when you are asked about the domain and range questions. So it's a good idea to know what the features of the graphs are, main key features, and how to answer the domain and range questions. So you should be able to sketch y equals natural log of x. This should be an automatic reaction from you. So first of all, you need to realize that natural logarithm has got one asymptote. So asymptote is when x is equal to 0. So this is the y-axis. This is the asymptote. It's not defined for anything that's equal to 0 or less than 0. So the domain is x is greater than 0. Now, when is y equal to 0? So when does the curve cross the x-axis? That will happen when you've got ln x equals to 0. So x is going to be e to the power of 0, which is 1. So this again should be an automatic reaction. It always goes through 1 on the x-axis. And then if you try to put different values of x, you'll see that this ln x is an increasing function. It gradually goes up and up forever and ever. It really looks like it slows down. And some people might think that there is an asymptote that's horizontal. There isn't. The graph goes forever. So the range is y belonging to real values. So you're going to get all possible values of y for x's that are positive. So this is what it looks like. Okay, so knowing that, you can now sketch any transformed graphs. I would not recommend sketching an ln of anything like this by using transforming graphs. All you need to do is do the following. First of all, find the asymptote. You do it by making whatever the ln is of, so this bracket, equal to 0. So it's 2x plus 3 is equal to 0. The same way this asymptote happened when you made that x equal to 0. So the asymptote is minus 3 over 2. Okay, the next thing you need to find where it crosses the x-axis. So the X Axis Intercept. So either make this equal to 1, because it happened when that was equal to 1, or solve when y is equal to 0. So just for practice, let's just solve it. So this is e to the power of 0, which is 1, is equal to 2x plus 3. So 2x is equal to minus 2, so x is equal to minus 1. And you're almost ready to sketch it. So the asymptote was x is minus 3 over 2. It passes the x-axis at minus 1. But you might think, well, is it going to be looking like this or like this? So if you're not sure, all you need to do is check, in this case, whether it crosses the y-axis, because clearly it will cross the y-axis. So let's solve x equals to 0. So what do I get when x is equal to 0? So ln of 2 times 0 plus 3, that will be equal to ln 3. And that's clearly greater than 0. You can check it on the calculator. So ln 3 is 1.098, so it's greater than 0. So this is ln 3, and that's -1. So the graph has no choice but to go like this. There you go. Okay, so let's have a look at this graph over here. I'm actually going to use a different piece of paper because I'm very quickly run out of space. So example 3, let's sketch y equals minus ln of x plus 5. So let's use exactly the same approach. Don't worry that there is a minus, that will be dealt with in a minute. So the first thing to do is to find the asymptote. For the asymptote, you're going to make whatever ln is of equal to 0. So that happens for x equals minus 5. The ln graph will always cross the x-axis, so solve y equals 0. So minus ln of x plus 5 is equal to 0. So give it an e. So ln of x plus 5 is equal to 0. Give it an e there. X plus 5 is e to the power of 0, which is 1. So x is equal to minus 4. So you can start sketching it. The asymptote is at minus 5, and it crosses the x-axis at minus 4. But is the graph going to go like this or like this? So obviously it will, now you can see that it will cut the y-axis. You can identify where it will intersect this axis by setting x equal to 0. So when x is equal to 0, y is equal to minus ln of 5. Pop it into the calculator. Minus ln 5. That gives me minus 3.55. So it clearly crosses the y-axis over here. So this is an inverted ln graph, which I expected because there's a minus, so the other one was flipped in the x-axis. Let's look at example 4. This time we have y equals ln 5 minus x. So again, asymptote. So we make x minus 5 minus x equal to 0. So x is equal to 5. The second thing, we need to find where it crosses the x-axis. So make y equal to 0. We'll have ln of 5 minus x equals to 0. Give it an e to the power of 0 is 1. So x is equal to 5, take away 1, which is 4. So we're going to begin sketching it. So the asymptote is 5. So at that point, x is equal to 5. That's the asymptote. And it intersects the x-axis at 4. Again, here we are lucky that the graph will intersect the y-axis. So it's either doing this or that. So I have to find the intercept with the y-axis. So make x equal to 0. We'll have y equals ln 5 minus 0. So ln 5. So this is going to be 3.55. So it's going to cross the y-axis over here. So it has to look like this. So it tends to the asymptote over here. If you had a graph that cuts the x-axis here and the asymptote is over here, then find another point. So sub another value of x to identify whether the graph will go like this or like that, because you won't have the y-axis to consider. And this one was minus ln 5. There you go. So that was a natural logarithm. So let's have a look at exponential graphs. So with the exponential graphs, the first thing you need to realize that there will be a horizontal asymptote. The horizontal asymptote is always, you cover that bit and that will become 0. So it's y is equal to 0, and that is the asymptote. So asymptote y is equal to 0, which is your x-axis. Now, where does it cross the y-axis? So when x is equal to 0, y is going to be equal to 1, so it's over here. Now this is an increasing function, so you can check another point, but you should know that e to the power of x always looks like this. So for the second one, this is going to be quicker. This one actually you can consider as if, you know, that was transformed, so shift it up 5. But identify an asymptote, just cover the bit that you've got with e. So completely that goes to 0. You're left with y equals 5. So that is the asymptote. When x is equal to 0, you will have the intercept with the y-axis. So it's e to the power of 0 plus 5, which is 6. Again, if you're not sure if it's decreasing or increasing function, check another point, but you should know that it's positive plus positive, and it's growing function over here, so it's simply this function shifted. Okay, here's another exponential graph. Let's cover the bit with e completely. You'll be left with, replace it with 0, so the asymptote is y equals 0. Find the intercept with the y-axis, so make x equal to 0. You'll have y equals to 2, e to the power of 2 times 0 plus 1, so it's e, which is about 2.7. It's again an increasing function, so this is what it will look like. And that's the value of that intercept is e. This one here, again, I don't think you need to really worry about this one. This is just the reflection of that graph in the x-axis. Again, you can have the same approach as before. So cover it up, you'll have y equals 0, that's the asymptote. Make x equal to 0, so you have minus e to the power of 0, which is minus 1. And it's a decreasing function. If you're thinking you will get it wrong, plot another point, so maybe check what happens when x is equal to 1 and sub it in and plot that point, and it will tell you that you've got to 10 to the asymptote from the left. Okay, this one here, we are going to cover the bit that has e, replace that with 0, so the asymptote is y equals 4. Now you need to find the y-intercept, so make x equal to 0, so y is equal to 4 minus e to the power of 0, so 4 minus 1, which is 3. So now, is the graph going to do this, or is the graph going to do that? No matter which one you choose, it has to cross the x-axis, so find the, when y is equal to 0, what is the x-intercept? So solve 4 minus e to the power of x equals to 0, so e to the power of x equals to 4, giving us x is equal to ln 4. Now ln 4, if you put that into the calculator, you should get the value of 1.3 something. So it's going to go cut the x-axis here, and that value here was 4. So here's the graph. Sketching. Okay, and the last graph here is e to the power of minus 3x. Again, cover it up. So you've got y is equal to 0 is the asymptote. Make x equal to 0. That will give me y is equal to e to the power of 0, which is 1. So the graph goes like this. There is the asymptote, there is 1. But you might mistakenly draw the wrong way around, because it's either doing this or that. So what you can do is simply put another value of x. So let x equal to 4. What happens to 4 if I put e to the power of minus 3 times 4? So that looks like a very tiny number, because it's 6.144 times 10 to the power of minus 6. So that's 6 in the 6th decimal place. So it's 4, so it's for 4. It's really close to this x-axis, so it looks like this. There you go, should go through 1. There you go. So this is how to sketch your exponential graphs. finally, let's look at sketching reciprocal graphs. So you should know that 1 over x looks like this. It's 2 branches. You learned the 2 asymptotes, horizontal and vertical, x equals 0, y equals 0. So these graphs look slightly different. You know it's a linear expression over linear expression. So how do you sketch it without rearranging it? So you have, let's say, something over x plus a number form. So this is what you can do. You need to identify the horizontal and vertical asymptotes. So the asymptotes make the denominator equal to 0. So x plus 4 is equal to 0. So that gives me x is equal to minus 4. Now the vertical asymptote has to be y equals to something. So this is how you do it. You put y equals, and over here, what you're going to do, you're going to just take the bit parts with x's and ignore the numbers. So it's going to be x over x, and that will give you 1. So that's the vertical asymptote. So the graph starts to look like this. So x equals minus 4 is the one asymptote, y equals 1 is the other asymptote. So your graphs will go either, you'll have 2 branches over here, sorry, I'll go overwriting, or 2 branches over here. So no matter what you do, there will be some intersections with the axes. So let's make x equal to 0 and see where the graph crosses the y-axis. So let's put x equal to 0, y is equal to 2 over 4, which is a half. So that is going to be over here. So I'm going to now confidently draw my graph. You have 1 branch here and 1 branch over here. Now you've got this as a half, so you need to find that value. This is when y is equal to 0. To solve when this fraction is equal to 0, you just make the numerator equal to 0. So x is equal to minus 2. So that is minus 2. So hopefully this one is going to be a little bit quicker. Let's find the asymptotes. So the first thing you do, you make the denominator equal to 0. X is equal to a half. And the other one, you're going to put y equals, and you just keep the bits with x's. So x over 2x, that will give you a half. So let's sketch the graph. You'll have 2 asymptote, positive half, and in both ones, so x is equal to a half and y is equal to a half. So you either have the branches, this one here and one here, or 1 here and 1 here. So let's look for the intersections with the y-axis. So x is equal to 0. Sub 0 into that, that gives me y is equal to 0. So it goes through the origin. So I know I have to have a branch going through the origin. So there will be another one over here. And because I've already sketched it without trying to make y equal to 0, it would only take me to this point. And that's the job done. There's no more intersections with the axes. So let's do this one here. Oh, let's just find the asymptotes first. Put asymptotes. So make the denominator equal to 0. So 4 plus 2x is 0 when x is equal to minus 2. And then y is equal to 0. Then sorry, the y asymptote, we are going to take the x part from the numerator over the x part in the denominator, so it's y is equal to a half. Now find the intersections with the y-axis, so make x equal to 0. So you will have y is equal to minus 1 over 4. So it's going to go there. So clearly we're looking for that point of intersection with the x-axis, so make y equals 0. That will happen when the numerator is equal to 0, so x minus 1 is 0, so x is equal to 1. job done. Okay, so this one here, asymptotes. The denominator is equal to 0, so x is equal to 1, and then put y and just take the minus 4x from the top and x from the bottom, so you have minus 4. X is equal to 1 and y is equal to minus 4. Find the intersections with the y-axis, so x is equal to 0, you have 3 over minus 1. So it's minus 4, so it's minus 3. It tells me the branch will go over here, and there will be another branch over here. So that's minus 3, so I need to find that point. So simply make y equal to 0, and that will happen when the numerator is equal to 0. So 3 minus 4x is 0, x is equal to 3/4. There you go. So that concludes the video on extra graph sketches.